Welcome guys. In today's lesson, we'll be calculating the support reactions of a simply supported statically determinate beam using Python programming language. And to enable us code this problem in Python, I have created a sketch to help us understand the various formulas we'll be using for the code. On the screen, we have a simply supported beam with two supports. So on the left support, we have a hinge support, and then on the right side, which is at point C, we have a roller support. We also have a point load with magnitude P kilonewton at B, and that is L1 meters from support A. And then the roller support at C is also L meters from support A. Right. So in order to solve this problem, we would have to consider three equilibrium equations. So first of all, we will have to consider summation of our vertical forces must be zero. So summation of our horizontal forces must be zero. And then three, would also consider summation of moments equals zero. So summation of moments about support A and support C must also be zero. We'll have a vertical reaction at point A. Let us call that vertical reaction VA. And the vertical reaction at C, let's call that VC. Right, so let's try and implement the first condition. Right, so that is a summation of our vertical forces or summation of our Fy must be zero. So let's start off. So summation of our Fy equals zero. So, and then before we do that, let us try and establish our sign conventions. So we would take all upward forces as positive, all downward forces as negative, all clockwise moments as positive, and all anti-clockwise moments as negative. If we consider the vertical reaction, that is VA at support A, it is an upward force, and we've established that all upward forces, the sign convention will be positive. So we'll have our VA, which is positive, so VA, right? And when we consider support C, that is also an upward vertical reaction. So that will also be VC. And then we consider the point load at B, that is a downward force, so minus P, and all must be equal to zero. So if we work this out, we'll have VA plus VC equals P. So that is the first condition, right? Summation of horizontal forces will not come into play in this example because we don't have any horizontal reaction or load on this beam member. So 2, summation of moment. So let's take summation of moment about A, support A equals 0. Right. So when we consider our sketch, right, if we are taking the moment at A, that means we are fixing, right, A and releasing support C. So if we fix the support A and release C, we'll have the P kilonewton acting on C having, so that will have a clockwise moment, right? So that will be a positive moment. So we'll have, so P multiplied by its lever arm, which is L1 from support A, so L1. And then we have VC also, that will also have an anti-clockwise moment about A. It is trying to push the beam up, because of the vertical reaction here. So that will be a negative, because a negative moment, right? So negative, so the magnitude of the force is VC multiplied by its lever arm. So that will be the summation of L1 or 2, which is L, right? So times L, all equals to 0. If we solve this, we'll have P, so P times L1 equals VCL. And since we are looking for the support reaction, so our VC will be so P times L1 all over L. So this will be the formula that would return the support reaction at VC. So if we slot into the equation here, so let's call this equation 1, we'll have the value of our VA. So our VA from equation 1, our VA is equal to the P minus VC. And we know our VC to be P times L1 over L. So this will give us our P minus P L1 on L. Right, so that will give us the support reaction at A. Right, so we'll be using the Anaconda package, and within the Anaconda package, we'll be using the spider environment, right? So spider, this environment. Okay, so you create a new file, and then straight away you can start coding. So from the previous lesson, we were able to establish the formulas for the support reactions at VA and VC. So in order to implement this in Python, we would create a function or a bucket to hold these formulas, right? So the first thing we are going to do is to define a function to return the value of our VA. So the support reaction at VA. So let's comment that out. So hash, and then we'll see, so calculate support reaction at A. Right, so we are going to define a function. So let's call that function. So define a function. Let's call that function. So VA underscore calc. And that will have parameters. So from our VA formula, we need the parameters P, L1, and L. Okay, so we need the parameters P, L1, so L1 and L. And we need a semicolon at the end because it's a function. Then, so we want to return the calculation for VA. So we'll say return. So we had our VA to be so P minus PL1 on L. So that will be P minus P multiplied by L1. So this will be, you need to put the P and L1 into brackets. So into bracket, then divided by L. Right. So that will be the function to return the VA, the support reaction at A. So that's VA. And then again, let us do a function for the support reaction at VC, at C, so VC. So that with that also define a function. So define a function. Let's call that VC underscore calc. And that would also have parameters. So our VC, that will also have the same parameters as VA. So P, L1, and L. So P, L1, and L.
and then we'll need a semicolon at the end, and then we are going to return. So return VC. So for VC, P multiplied by L1 on L. So that will be, so P multiplied by L1 on L. Right, so that will be our function to sub. So let us comment this also out. So we can copy the first comment and bring it down here. I'll change that to C. Okay. Right. So we've been able to define two functions, one for the support reaction at A and the other for support reaction at C. The next thing we are going to do is to allow the user enter the the span dimensions and then the value of our point load. Right. So the user must be able to enter the value of this point load here, and then the distance L1, the distance L2, and then we'll do a calculation to return the distance L, right? So coming back,